So today the next topic is about Lorentz half-shade polarimeter. So in the previous session we seen about optical activity and what is the optical activity and how it is formed, and we also seen about specific rotation. Now today the theme is about the Lorentz half-shade polarimeter. So polarimeter is a device. Okay, so it is an instrument used to measure the specific rotation or the optical activity of a substance. Listen, the optical activity phenomenon is measured with the help of a specific rotation. Now, polarimeter is a device which is used to measure the optical activity of a substance or the optical rotation of a substance. Now, so this is the diagram of the polarimeter, the device. Okay. What are the things are appearing in the polarimeter? Lens, polarizer, analyzer, and vernier calipers. Okay, the telescope T, and the glass tube, and half-shade device. Okay, now how the polarimeter measures the specific rotation means, see, a lens is there and two nickel prisms are there here. One nickel prism acts as polarizer and one nickel prism acts as analyzer, and behind the polarizer, the nickel prism N1, half shade divide is placed, and behind that a glass tube is placed with a wider diameter. Okay, so the glass tube stores the optical active substances. I also explained the examples of optical active substances. Now the optical active substances is placed in this glass tube which has a large wide diameter. So the solution is filled in such a way that there should be no bubble, formation of bubble in the path of the light. So where will be the bubble will be stored? The bubble will be stored at the bore of the tube, glass tube. So beside the glass tube, an analyzer is placed with the help of the telescope and vernier calipers. Now this is the construction. Okay, this is the diagrammatical construction of the polarimeter. Now move to the working of a polarimeter. How it works means, suppose here we are incidenting a light from a source. So if we uses an unpolarized light and passes through these converging lens, if a unpolarized light passes through this converging lens, then it falls on the polarizer. What the polarizer will do? It completely polarizes the unpolarized light. Now the polarizes produces the plane polarized light. It makes the unpolarized light to a plane polarized light. Now the plane polarized light, after producing through the polarizer, then it passes through the half-shade device. So the name itself indicates that half-shade divide means it consists of a half wave plate. I also taught you the half wave plate and a quarter wave plate. So half shade device consists of two half wave plates. One half wave plate will be made up of quartz and other half wave plate is made up of glass tube, glass. Okay, so the amplitude will be same. The amplitude of the light passing through the quartz and the glass plate will be same. So the incident light will be same throughout through the quartz light and also the glass plate, quartz plate and the glass plate. Now if polarized light enters through the quarter wave plate, okay, then it also enters through the glass wave plate, glass half wave plate. So both the half wave plates, okay, both the half wave plates are inside of the half shade divide. Now if a polarized light passes through this half-shade divide, it is going to be passes through the quartz material and also it passes through the glass material. So after passing through it, it enters into the path of the light, enters into a glass solution. Okay, now these optical activity substance, after passing the light through this glass tube, okay, it then moves to the analyzer. What the analyzer will do? It analyzes the polarized light, the plane of vibrations of the plane polarized light. So this will be noted through these with the help of the vernier calipers, and viewed this, all the entire thing will be viewed with the help of telescope. Means how it will be appear means, if a plane polarized light passes, suppose if a plane polarized light passes through the glass plate, half wave plate of the half shaded device. So suppose it follows a path of AB. If it is passing through the glass plate, it follows through a path AB. After passing this ray of AB, then it enters through to the glass tube. Okay, after incidenting a polarized light on the half-shade device, passing through glass tube, glass plate, then it falls on the optical active substances which is stored in the glass tube. Then what happens? It allows the phenomenon of optical rotation. Okay, the optical activity substance shows the rotation phenomenon. Then it rotates at an angle, it makes an angle theta. The path AB makes an angle theta with y dash. Okay, suppose if a polarized light passes through the quartz wave plate, then it follows the path of CD, and again it makes an angle of theta, but the directions will be different. Okay, then it makes an angle of bisection. What the angle of bisection? AOC, and also BOD. Suppose O be the origin, so AOC forms one angle and BOD forms an one angle. Okay, next, so after passing the light through the glass tube, it completely viewed in the analyzer. So analyzer is adjusted in such a way that it should be produced equal brightness. Okay, it should produce the equal brightness of the both the sides. So it should produce brightness on the quartz side, and it also should produce the brightness on the glass plate. Now actually the analyzer is adjusted in such a way that completely the optical solution, suppose if you took the sugar solution, that completely it is removed from the glass tube. So if we remove the analyzer is adjusted, for the adjustment of analyzer we have to remove the solution, sugar solution or optical active solution. Then what happens when if we remove the solutions, what happens? The light completely passes through the polarizer, then half shade divide and falls on the analyzer. So then it produces equal brightness. So it is adjusted in such a way that, so to know the difference, we again place the, okay, after adjusting the analyzer position, we repeat the experiment with the help of the, by taking the sugar solution. So if light ray passes through sugar solution, what happen means, if the analyzer is the plane of vibration or the plane of polarization is rotated in clockwise direction, okay, rotated in clockwise direction, one part will be with brightness, and one side will be with empty. And if we rotate the analyzer, okay, if we rotate the plane of polarization, okay, plane of polarization in anti-clockwise direction, so in that it produces a diagram of one part will be, again the left part will be completely disappearing, and one part will be completely brightness. So this is the how we will make the measure of the optical active substance. So if the analyzer, okay, if the analyzer rotate in a clockwise direction, that is the right of the y dash, then the right half is brighter than the right half will be brighter than the left half. Suppose if analyzer is rotated in the anti-clockwise direction, that is the left of y, okay, that is the left of y, then the left half will be brighter than the right half. So I already explained in the previous video what is the formula of specific rotation, that is tan theta by LC. So what are the units? Theta is measured in degrees and length in decimeter, and concentration is gram per centimeter cube. Okay, so this is the complete theory of off-shade polarimeter. So simply we can mention that polarimeter is a device which is used to measure the optical active substance. And the construction, what is the construction of the polarimeter? One lens, polarizer and analyzer. Both the polarizer and analyzer were nickel prisms. One nickel prism is used as analyzer and one nickel prism is used as a polarizer. Then behind that a half-shade divide is used. This half-shade device consists of two half-wave plates. Okay, these half-wave plate made up of one half-wave plate made up of quartz and one half-wave plate made up of glass material. So if emergent light passes through the polarizer, it completely plane polarized light. The plane polarized light will passes through the half-shade device, that is quartz plate and the glass plate. So if the light passes through the quartz plate, the light ray splits into two rays, that is extraordinary ray and a ordinary ray. So we are using the half-wave plates, then the phase difference will be 5 and the path difference will be lambda by 2. Okay, the phase difference will be 5 and the path difference will be lambda by 2. So completely after passing through the half-shade devices, a glass tube with a wider diameter, long diameter is used. At the two ends are covered with the cover slips, and two bulging bubbles will be placed fixed with that glass tube. So the glass tube is used for storing the optical solution or optical active substances. Okay, then completely after completing this construction, analyzer is used to analyze the plane polarized light and the plane of vibration, and we are adjusting our vernier calipers with the telescope for reading the measurements. What is the rotation made by the optical active substances. So this is the working. So for the analyzer adjustment, what we'll do, we remove the optical active substance, then we make a position like if the light falls on the falls on the glass tube with the empty solution, it should produce the equal brightness on both the sides. Okay, after adjustment, again the solution is filled to measure the optical substances, optical activity. So we are taking the sugar solution. Then if the sugar solution is filled, again the experiment is repeated. That is, if we are incidenting a light and it becomes a polarized, then passes the half-shade divide and it falls on the glass tube. So what happens means, if the glass tube, if light ray passes through a glass tube, it falls on the analyzer. So one half will be with brightness and one half will be the empty. So to make the equal brightness, both the path AB and CD are rotated in a clockwise direction, then it shows the path of the equal brightness. So for the analyzer, without solution there will be equal brightness. After solution is placed in the glass tube, then it appears when the ray passes through the quartz plate, it appears in one form, and if a ray passes the glass tube, it appears in another form. Okay, so we adjust with the equal brightness for an analyzer by making the path by using the rotation. By rotating an actual clockwise direction, so we make the view in a equal brightness. Then after becoming an analyzer with the equal brightness, by viewing the telescope, it is measured with the help of the vernier calipers. Suppose if the analyzer is moved in the right of the YY path, YY dash path, then the left half will be brighter than the right half. Suppose if the analyzer is rotated in the left of the YY dash, then the left half will be more brighter than the right half. So through this we can measure the optical activity, and the optical rotation is measured by using the specific rotation. So this is a complete theory of Laurent half-shade polarimeter. Thank you.